Okay guys, so in this video we're going to look at something called recasting, okay, or recasting. So what's happening here is we have a shape, in this instance a sphere, and it's melted down into a blob, and then it's recast, which means it's made into another shape. And what they will do is they'll give us one piece of information about that shape. So in this instance they'll give us that the radius is 10 of that new shape. And what they want us to find then is the height. Or they could give us the height and they might ask us to find the radius. So here's how we do it. And just to keep this in mind, whatever volume this sphere is, if it changes shape to the blob, it's still the same volume. And then if it changes shape, or we recast it into the cylinder, it's still the same volume. And that's, I suppose, the important thing to note about when we're solving these questions, right? So instead of recasting it the blob, I'm just going to recast it straight to the cylinder. So the first thing I need to do is I need to find the volume of this sphere. And to find the volume of a sphere, volume equals pi r cubed. So volume equals pi, which is 3.14 if we want, or 22/7, or just leave it as pi in your calculator, multiply by 5 cubed. And what that will give us is 392.5 centimeters cubed. These are centimeters here. Okay, so we have the volume of the sphere now. So if we come down here then, we can say volume equals, and we're going to write in the volume formula for the cylinder. So volume equals pi r squared h. And now we fill in what we know. Now I know the volume is 392.5. How do I know the volume of this cylinder is 392.5? Well, because the volume of the sphere is 392.5, and I just changed its shape to that, but there's still the same amount of volume or the same amount of stuff in it. Therefore, the volume of the cylinder is the same. I know the radius. So the radius is 10, I'm given it. I don't know the height. Now, we have here an equation with one unknown, and that unknown is h. And if I have one equation and one unknown, I can solve it easily enough. So 392.5 equals pi. We'll change that to 3.14. Multiply by 10 squared is 100. Multiply by h. So this is 392.5 multiplied by, well, 3.14 multiplied by 100 is 314 multiplied by h. So what I want is h on its own, so I'm going to divide this side by 314. I must divide this side by 314. And so this side, 314 multiplied by h, divided by 314 is just h. And this side, 392.5 divided by 314 is 1.25. So the height of the cylinder is 1.25 centimeters. So there we go. Okay, so next question. Very similar, but I just want to give you the history behind this type of question. So years ago, back in ancient Greece, there was a king, and he got a blacksmith he gave gold to the blacksmith to make him a crown. Blacksmith made the crown. However, the king was convinced that the blacksmith, before making the crown, took some gold out of the block he was given and then recast it into the shape of the crown and gave it to the king. Now, the king had no way of knowing whether the blacksmith took out gold or not before recasting it. So what he did was he asked Archimedes to find out if the king had taken the gold, took a little bit out of it, and then recast it as the crown. Now Archimedes was confused how to do that. The only way he could think of doing it was to remelt the crown into the block of gold again and see if anything was missing. However, one day Archimedes was getting into his bath and he filled the bath right up to the top, and then he got into the bath and the water flowed out. And at that moment he realised he had the answer. And he ran down the street shouting, "Eureka, Eureka," which means I've got it, I've got it. And what he copped was, if he was to fill a basin with water and put the crown in it, well, the amount of water that would spill out of the basin would be the same volume as the amount that the crown that he put in. And therefore he could get the volume of water, and he could see, was it bigger or smaller than the volume of gold that the king had given the blacksmith. Okay, so there's the history behind it. Here's a question. We have a sphere and we have a cylinder, and we don't really care about the height of this cylinder. We're not interested in it. But we have a sphere, and we have a sphere that's somewhat filled with water. And again, I don't really care how much it's filled with water. I just know it's somewhat filled with water. And the question is, find the height the water has risen. So when I take this sphere and I put it into this cylinder of water, how much does it rise? Okay. So here's the trick here. I don't care about the height of the cylinder, and I don't care about the height of this water. All I'm interested in is the bit that it's risen. But just like the casting, if I can find the volume of this, and then I just concentrate on the bit that it's risen, okay, so I ignore everything else, so I just concentrate on this bit, I'll be able to find the height that that bit has risen. So just watch how I do this. So the first thing I'm going to do is I'm going to find out the shapes I'm dealing with. So I'm dealing with a sphere, and I'm dealing with a cylinder. Why am I dealing with a cylinder? Well, because the shape of this is a cylinder, and therefore the shape that the water rises is a cylinder. Now I'm going to draw out what I have first. We don't have to do this, but just makes it easier. So the sphere with radius 4. Now all I am interested in is this part of the cylinder, the bit that the water rises. I don't care about anything else. So I can forget about all of that, and this is all I'm interested in. That cylinder shape that the water has risen. So I'll draw that. Again, we don't have to draw it, but it makes it sometimes more easy. Okay, now do I know the radius of that cylinder? I sure do. Look, it says it over here, the radius is 8. Okay, so just get rid of this, get myself a bit of space. The volume of these equal each other. The volume of the sphere and the volume of the amount of water risen equals each other. That stands to reason, doesn't it? If I take the sphere and put it in here, and there it is down there, well, the amount of water that rises is, the volume of water that rises is equal to the volume of what I put in, just like Archimedes found out. So, let both equal each other. Now, the formula for the volume of the sphere is pi r cubed. The volume for the volume of a cylinder is pi r squared h. I'm asked to find the height that it's risen. Often here I will just leave the pi's as themselves because I can cancel them out. Okay? But we'll put in what we know first of all. So leave pi as pi, multiply by the radius, which is 4 cubed, equals pi multiplied by the radius here, which is 8 squared, multiplied by the h. Okay, 4 cubed is 64. So it's 64 pi equals 8 squared 64 again, just coincidence that. Multiply by h. Okay. Now I have 64 pi on one side, 64 multiplied by h on the other. I have an equation. I'll divide by pi on both sides to get rid of the pi. Divide by pi. 64 pi divided by pi is just 64. 64 pi multiplied by h divided by pi is 64 multiplied by h. I want to just have h on its own. 64 multiplied by h. I just want h, so I'm going to have to divide this side by 64. I must do the same to the other. 64 multiplied by h divided by 64 is just h. And 64 divided by 64 is 1. So the h equals 1. So the height that this cylinder rises, or the water rises, when I put the sphere into it is 1 centimeter. Okay, I hope that helps you guys. And just for my own class, because we're in lockdown now, and for anyone watching this video in a few years' time, at the moment we're in lockdown. So, my second years, the homework, please do page 402 and 403, questions 9 to 17. Okay, some of them are tricky, some of them are handy, and we'll correct it then on the Tuesday, the Thursday, which is our next Zoom class. Okay, thanks guys.